Okay, so the first programming concept that I'd like to go over is variables. So variables are just a way of storing a particular piece of data or value under a name. You can think of it like a box that you put a label on, and then you can store something in that box. So this can be really useful in programming because throughout your program you can change the value and you can reference it by name rather than just using the specific value, which you might not know at any given moment. So think about a video game, for example. In a video game, a player might have health points or lives, and that could be stored in a variable within the code. And then, you can subtract and change that value as things happen in the game, and you can reference it as well if you need to do some kind of calculation, or if you need to, for example, display it on the screen. So variables are really great for that, and they're great for a lot of other things. So they're really easy to write in Python. So I'll show you just a quick example. This x equals 5. This is an example of variable declaration in Python. So we have a variable named x, and the single equal sign indicates assignment. So what we're doing is we're assigning the value 5 to a variable named x. So anywhere else in my code, if I use the name x, so for example, if I just type print x, it's going to recall whatever the value is currently for x and print that out. So here the value is 5, so it would print out 5. If somewhere else in my code this value for x changes before it hits the print line here, it's going to print whatever the current value is. So what I'm going to do is I'm going to show two examples, and I'm going to ask a few questions with those examples. And if you'd like, you can pause the video and try and answer them for yourself. But I'll go right ahead after and answer those questions for you. And then at the end, I'm going to write in an exercise. And I highly recommend you pause the video at that point, try it out for yourself, and once you're done, return to the video and I'll show the answer for the exercise. So first example looks like this. X equals 3, y equals 6 times x plus 5, print y. So the first question is, what are the names of the variables used in this example? The second question, what will be the output of the program when it is run? So think about those for a second. First, what are the names of the variables used in this example? So I mentioned earlier that variables always use assignment with a single equal sign. Anytime you see a single equal sign, that means assignment to a variable. So we see two equal signs here, so then we know, okay, here we're assigning this value of 3 to a variable named x, and here we're assigning whatever the result of this is to a variable named y. So there are two variables used in this example. On this last line here, print, we're not assigning anything. There's no equals here. So there's only two variables. And the names are x and y. Okay, next question. What will be the output of the program when it's run? Well, it's printing whatever y is, and here we have y is being assigned to the outcome of this. So 6 times x, which in this case is 3. So we're backtracking a little bit here. So we know that x is 3. So if we fill that in here, it's 6 times 3 plus 5. So that's 18 plus 5, so the answer is 23. And of course, the most fun way, I guess, to figure out what the output of the program is when it's run is to just run it. So we can just click run, and you see, yep, 23 is what gets printed out. Okay, the second example looks like this. N equals 200, profit equals minus 0.1 times n to the exponent 2 plus 64 times n minus 4,340. Print the profit is, then on a new line, print profit. So the questions here are, what are the names of the variables used in this program? What operation does star star 2 indicate? And that's it. So these are the two questions. First one being, okay, what are the names of the variables used in this program? Same thing applies. We see two equal signs being used here, which means two values are being assigned to variables. These are just print statements, so they don't count. So we have a variable named n that's being given the value 200, and we have a variable named profit, which is given the value of whatever the result of this is. So the second question is, what operation does star star 2 indicate? So if you remember from the earlier video where we talked about arithmetic, I think it was the last video, the double star is for exponents. So this would be the exponent 2. We're using it right here on line 5, where we take whatever the value of n is currently, which is 200, and we put it to the exponent 2. So let's give this program a run just to see what comes up. And we can see on one line it says the profit is, and on the second line it prints out the actual profit, which is 4,460. Okay, now it's time for the exercise. So we'll start it like this. A rectangle has a perimeter of 450 millimeters. The questions are as follows. Write a program to determine the length of the rectangle based on its width. Use a width of 150 millimeters, but design your program so that the width can easily be changed to calculate another length. Next, modify your program such that the rectangle's area is displayed along with its length. And then the last question, modify your program such that only the rectangle's area is shown, but the area calculation is done in a single line. Okay, so let's start. Or actually, before that, I should say, you should pause this video and try it for yourself, but I'm going to start with the answer. So, first part, write a program to determine the length of the rectangle based on its width. Use a width of 150 millimeters, but design your program so that the width can easily be changed to calculate another length. This part here, design your program so that the width can easily be changed, lets us know that the width should be used as a variable, so that we can easily modify its value later if we have to. So I'm going to go ahead and make a variable first called width, and set that to 150. Next thing we do is we calculate the length, and so the total perimeter is 450, and we subtract double the width from that, and that would give us both of the lengths. And so what we need to do next is take all of that and divide it by 2, and that gives us the length. And then we can just print out the length is length millimeter. Now you don't have to write the print statement like this. This is just how I prefer to write it so that it all shows up on one line, which you'll see. But you could have just as well written the length is and then the length on a new line, or if you wanted to, just print the length like this, which is also completely fine. Okay, so if I run this program, you'll see it says the length is 75 millimeters. Okay, let's move on to part 2. Modify your program such that the rectangle's area is displayed along with its length. Okay, so we need to add a step here to calculate the area. So we'll make another variable called area and set that to length times width. And we'll also add another print line here to say that the area is followed by the actual area value and square millimeters. Okay, if I run this now, we'll see that it says the length is 75 millimeters and the area is 11,250 square millimeters. Okay, time for the last part. Modify your program such that only the rectangle's area is shown, but the area calculation is done in a single line. Okay, this is fine. So first, let's address that first part. Only the rectangle's area is shown. Okay, so let's just remove this line where it shows the length. And then the last part, make sure that the area's calculation is done in a single line. Okay, so right now we're using 2 lines because we have to calculate the length first, and then we calculate the area here. So what we can do instead, because ultimately this length variable will evaluate to this value here, right? We can just cut that value out, paste it in here, and just so that we know that it's separate and it's its own thing, we can wrap it in parentheses. And we can see then, okay, this is the length and this is the width, which is we're calling from here, and we can remove this line. So if I press run here, we should get the same result. Yep, it says the area is 11,250 square millimeters.